Look at the sine function here. Look at the sine function. My claim to you is that there's an issue here. There's a problem. How do I get an inverse of this function? That's my claim to you. Well, would you just go out and start switching x and y and go your merry business? What's the first thing? Yeah, well, then you're not going to be too merry when you're done, I'll tell you that. What do you have to do first before you start finding an inverse? Sorry? Say that one more time, loud and clear, so that Shika, who's not paying attention there at the back, can hear. What about the horizontal line test? What is the horizontal line test? Exactly. If you were to draw a horizontal line on this graph here, how many places is it going to cut the graph? Many, 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 many places. Okay? So theoretically speaking, if you want to look at this graph, there is no inverse. Okay, but we can fix that. We can fix that. Take a look at the graph between minus pi over 2 and plus pi over 2. Okay? The graph looks... So here's 0. Your graph looks something like this. Does everybody buy that? My claim to you is that this is unique. The whole graph that you see here that goes on and on and on and on can be done by just knowing that piece there. Because look at this piece. Isn't that the same as this? Isn't it going to be the same somewhere else? Isn't this piece the same as this one except it's reflected over? Do you guys see what I'm talking about? Okay? So this is really, really unique. Which means that if I restrict my domain of sine to be between minus pi over 2 and pi over 2, then I can start talking about the inverse of that function. Because at this stage, does it pass the horizontal line test? Yeah, it does. Because if I draw a horizontal line, it cuts it only at one place. And I'm good. You guys with me on this? Okay. So let's take a look at and do a little bit of a review for, don't worry about that. Let's kind of fill this table in because this is something that you've done before. So I'll give you a minute to finish this table. So I'm looking at this table here where we've seen the domain of sine cosine. Sine domain? Minus infinity to infinity, parenthesis, range. Right? Bracket. Okay, bracket. Okay. Emily, cosine. Domain. Nice. And nice. Good job. Ashwarya, let's see if you know the domain on tangent. For domain? Well, remember, tangent is really funky, okay? It's got asymptotes. Oh. So you got all real. Okay, so 2n plus 1. Odd multiples of pi over 2? No, odd multiples of pi over 2. Okay, and range? Okay, so the way to write this for domain is all real x not equal to 2n plus 1 pi over 2. Sorry? Not u, x. Where's the u? There is no u. What equation are we talking about? No, it's not 2u. It's x not equals. Okay? Alright, so we agreed that we need to restrict the domain in order to get the inverse. Right? Right? Why do we need to do that? Sorry? No, it would be a function, but it would not be... What's the right technical term? I thought I heard you say that. Sorry? No, what's the right technical term for a function to have an inverse? Sorry? No, that's the proof. What should a function be so that you can get its inverse? 1 to 1. 1 to 1. Okay, 1 to 1. The function's got to be 1 to 1. Okay, so now what we need to do is we need to restrict the domain, and we need to rewrite this table with the restriction in there, okay? And so the restrictions are right there. Right there. Okay? So that's the domain of your sine, cosine, and tangent if you want an inverse. Can you guys copy that down in your notes, okay? It's on the board there. Yeah, except those will be the numbers you'll be using. The range doesn't change. The range doesn't change. Okay? So sine, cosine, and tangent. Okay? So to get an inverse, sine is going to be restricted between minus pi over 2 and pi over 2. So that's the domain we are talking about. The range doesn't change. Okay? Cosine, notice, is from 0 to pi. And tangent is minus pi over 2 to pi over 2. Okay? Right? All right, so make sure you understand what this means. Now let me just go back and kind of review what an inverse really means, or what the original function means. Okay, notice that you have a sine of n, always of n. Sine is always of n. What quantity? What quantity? Of n. What's that thing called? Okay, it's always off an angle. Sine or cosine or tangent is always off an angle. When you do that, you get stuff. Okay? Inverse function, you do the inverse on stuff, and you get an, that angle had better satisfy this. So it's got to be in radians. It's got to be between minus pi over 2 and pi over 2. Okay? Always in radians, and always satisfy that domain for sine. Okay?